Hello. The purpose of this video is to illustrate the use of random forest model and the bag of words model on, the restaurant reviews on Yelp. My audience is my professor for my class, and that's the format that this video will be. But if you find the video useful, then that's very good. So let's start with the first block. This is where we import some of the things we need. The first line is, of course, to have the figures show up on the page when we plot something. And you can see some of the other things I had to import in order to make this work. I should note, for the class we were using a Mongo database that was installed on the class server, and we were all accessing it through the internet. Now, because of my connection issues and so on, I was forced to create another Mongo database on my local machine here, which I'm running right now, and I had to install the Yelp dataset, the Yelp datasets onto my local machine because it was taking too much time for me to query and make requests. So here we create, I create a Mongo client, and on this line I'm collecting. So this line here returns a cursor object. That's why the variable is called my cursor. And here I query for all the businesses that are restaurants on this database. Here I'm just printing a count of the number of businesses that were returned. So there were 303 businesses, restaurants returned by this query. Now here we see a repeated line of code, so this is a duplication. It's not necessary. Now, what I did here is I created a list, and I would whenever a restaurant was returned, I would put the restaurant ID, the business ID of that restaurant, into this list. And this is what this for loop is for. As you can see, I append the business IDs onto the list, and right here, the reason I'm using lists, I'm using two lists here, is because it still takes a considerable amount of time for me to make requests, and these for loops, especially this second one, second one right here, would take about 20 minutes. So that wasn't feasible. I decided to put all the reviews into one giant list, and I found out that it was much easier and much faster to access the reviews using this method. So these for loops basically add all the reviews for the 303 restaurants into a single list. So this list includes all the reviews for those restaurants. On this block, this was mainly for illustration purposes and for me to gain a better understanding of the most frequently used words here. So I used the NLTK package, the NLTK module, frequency distribution. And first I had to clean whenever I would, so for each review I would have to clean the review to get a better distribution or illustration of the most common words. So here we tokenize the words. We create a list of stop words, and then we remove anything that is not an alphabet. Then after that we remove all the stop words that were defined by NLTK itself. Now you can do more processing, but this was sufficient enough for me. We will do some more, just a little bit more here. We remove I and D, and then we'll leave it at that. And then I created a frequency distribution object, and then I would, for each review, and then I would add the distributions to each other. And of course we turn everything to lowercase because it doesn't matter in our case if the words are in uppercase or lowercase, if the letters are uppercase or lowercase. So again, we remove I and D, and here I have printed the 40 most common words after all the processings, and you can see food, good, place, like, service, it, and so on. And you see the count of each word. So this was all generated by NLTK, which is very useful, by the way. Here I'm just this is again for tests for my use mainly. It shows that there are roughly 1,800 reviews in my list, and I just show one of the reviews here, just to again see what the format is like and to remind myself when I'm trying to write code. It's always nice to have some example. Now, if you recall above, we did some normalization of each of the reviews, the review texts, basically, before running our frequency distribution on it, and to get the most common words. Now this is a helper function that does that basically. So it takes a raw review and it converts it to a string of words, and the words have been normalized. So the stop words are removed, anything that is not an alphabet is removed, and that helps a lot. And then we join the words back together, and we return a lowercase set of words as a string, and we call this function later on in our code. So here I create another list, a copy of the review list that I created a while ago, the list that includes all the reviews for the restaurants. And the reason I do a deep copy is because I don't want to change this, because if I change this and I decide that it was a mistake, then I would have to go through another 20 minutes of basically querying the database and building the list again. So I try to avoid that, so that's why I use this command and not just equal here. And I will do some more processing on this and normalization of the texts, review texts before using it on the using the random forest model. So I then turn the clean reviews list into a data frame. It's easier to manipulate data frames. That's why I decided to go with that. So this is the pandas object. PD is pandas. It was imported initially, if you recall. And I just print the clean reviews just to see visually what it looks like. This is what it looks like. So our focus is mainly on text and stars. That's what matters. We try to use text to predict the stars. And for stars, we have three categories. It's either good, it's neutral, or it's bad. And the way we show it is by +1, 0, and -1. -1 being bad, +1 being good, 0 neutral, 0 being neutral. So this is what the data frame looks like right now. Now if you look here, you see that this is a capital letter and there is a dot here. So these have to be removed. We have to normalize the text before running our analysis. Again, this is just to show that there are roughly 1,800 rows, 1,800 unique reviews, assuming that there are no copies of each reviews, but this is how many reviews we have on our data frame so far, and that number remains unchanged. We don't change that. We just divide the reviews into a training set and a testing set, but the aggregate number stays the same. So here I just, again, for my purpose, for row 0 and column 5, I get the first review text. This is again showing that there's a dot here. There's 30, which is not an alphabet, and there's a capital letter. We have to take care of that, and in order to get a better understanding of what's going on and have our model be more accurate. Here I get the number of reviews, and I then create another data frame which holds the stars group, and that basically is the 0, 1, and -1. So if it's good, neutral, or bad. If it's good, it means that it's above 3, meaning it's either a 4-star or a 5-star. A 3-star is a neutral, and anything below 3 stars is bad. So 2 and 1 are bad. I'm not sure if there is 0, but if there is 0, then that would also mean that it's -1 and it's bad. So this is the code that first cleans each of the texts, the review texts, using our helper function, and replaces that. So afterwards we should have we shouldn't have any non-alphabets, and we should not have any capital letters, and so on and so forth. And then we also should have another column which holds the stars. The label of the column should be stars underline group, and we will see that. And this is the code that we use to build the column and clean the review text. So here I call the clean reviews, again the data frame, to show that it has been changed. So this is the star group. This is a new column, 0s and 1s and -1. And the texts, if you recall, this was a capital A, and everything else has also been handled. It's been cleaned quite a bit. It's good enough, basically, in my opinion. Now, in order to have an objective analysis, I wanted to, well, you have to divide your data set into a training data set and a testing data set. Now I wanted to do that randomly. I didn't want to choose the first 80% as my training data set and the rest as my testing. I wanted to randomly select randomly build my data sets. Now the way I do that is by using a random shuffle, and this X will hold the indexes, and what it will do is I can actually show it to you. So if we run X, you'll see that it's a random collection of numbers within from 0 to the length of the clean reviews, now I just noticed a problem. I don't like calling the length of clean reviews. I much rather call the index, because that's the number of rows, and it's better coding practice in my opinion. So I will change that right here. So again, we get a random number. Now that did not change anything, but I did check, x was still 1849, and the length of the maximum number that x could be was 1848 basically. But so nothing is incorrect, but we will run everything again just to make sure. Now here we create the training, the number of reviews that we want in our train data set, and the test data set, which I use 80% and 20%. And here we create a data frame for the training data set, we call it this, and the test data set, and we call it clean test reviews. So these are both data frame objects. And if you want to look at the code, this is, if I can show it to you, this is what the code looks like. It is a good idea to ignore indexes, because indexes make no difference here, and on this block here it would actually make a difference on your output. So as the printing suggests, here I create a bag of words using Scikit-Learn, and first we will use 10 as our maximum number of features. Maximum number of features is basically the number of words that we will use. So we will use 10 words, 10 classifiers for this analysis, and later on I will actually use more and more, and our test score will actually get better and better as we do that. But this is just to show that you do get a lower number if you use a lower number of features, which is obvious, but it's also there is a cost and benefit, and there is a trade-off in how much resources you want to use and how accurate you want to be. Here we train the data features, and this is on our training data set, and we're using the review texts for this analysis. And also you can read in the comment what it does exactly, what this fit underline transform. Be careful with this underline, because once you run the fit on the test itself, you have to use a different command which is similar to this one. And you can see what this command does, and we're just converting this variable to an array. Now here we can visualize the vocabularies, the features that we're using. Then we're using food, go, good, great, it, like, and so on. If we're using 10 right here, but later on we will use much more, and in the thousands. I think that the maximum that I will get is 5,000 words, and that's the maximum that I will allow. I don't think we might not use all the 5,000 words, I'm not sure, but that's the maximum that I will use for the model, for the random forest model. And here I print the features again, and the number of instances that they appear. So food appears 1,000 times, and the appears 1,400 times. And I should note that I'm not sure if these 10 features are the top 10. In fact, if we go up here to the frequency distribution that we had, there is service here, which is the 1, 2, 3, 4, 5, which is the 5th. And let's see if we have service here in the features. We do, but it's quite down there. And let me do a check here. Okay, these do appear to be the top 10 words roughly. Not roughly exactly, but the reason I say roughly is because our processing might be different, so some of the words might end up being different. But remember, our normalizations are different for this frequency distribution and the one that we use for in our helper function, which being used for the analysis itself. So you will be using the top 10, 20,000, whatever maximum number of features that you specify. And here I show again, as I've said, I did go over this. So food appears this many times, go this many times, and so on. As we went through this, we trained the random forest. We're using our training data set, and we create a random forest classifier object, and the number of estimators is the number of trees. Here I use 5. Later I will increase that to 100, and our score will go up significantly after increasing this and the number of features. Here I create the bag of words. So first we vectorize the texts, and we turn this returned array, which is the bag of words, into an array, and we use a random forest to make label predictions, and sentiment is maybe not the correct word. We're using stars rating label predictions, maybe stars rating group prediction, and we add a column named predict, and what I do is, again, this is how I do practice coding. I create a deep copy of this data frame. This is how you do it. So whenever I manipulate this output, which I do, I don't end up manipulating this data frame, which I don't want to do. I want to be able to easily go back and correct my code. And we output our predict, our result, into this column, and then we output our the result, the data frame, into a CSV file, which I will show you. And this is good to have. You can use this to run analysis on Excel, and you can use it to store it, and so on and so forth. Note here I am using the trained model on my test data set. That's why you see clean test reviews. And note the difference in the transform function. If you recall, with the other one, there are two transform functions. One is for training and the other is for testings. It's important to make that distinction. This is a print copy of the output data frame. You can see that the star groups are here, and we can see our prediction. Our prediction matches roughly. It's very close. The reason it's not extremely close is because, again, with the number of trees and the number of maximum features, once I increase that, you will see that the the score here increases. So the score here right now is 0.79 if we round up. And if we plot the original outputs, these star groups in blue, and on top of that the predicted outputs in red, we get this plot right here. So we have ones, zeros, and negative ones. Now if you see, most of the blues, vast majority of the blues are red because our prediction was right. But you see a lot of blues, quite a bit of blues here, and so on. Now, if once we increase our number of features and the number of trees, we will see that that number will increase. So I will increase the maximum number of features from 10 to, let's say, 40. Actually, let's go with 20. And let's change the number of trees from 5 to 10. So this, and we have to run everything again. I will be right back. So here is our new features. These are the features that we're using right now. And if we go down, we see that there are, first of all, our score went from 7.79, I believe it was, to 0.91, which is a significant jump. I believe this is 91% right now, but I'm not sure if it's percentage or not. But if we look at the plot, we see that there are significantly less blues visible because the reds, our prediction, covered the blues, meaning they were spot on. Now I will increase the number of features again from 20 to, let's make it 100 features. Actually, let's go with 50. And let's change the number of let's leave the trees at 10, and let's see what happens. So right now our score is 0.91. Be right back. So this is the new set of features that we're using and the number of instances that they appear in the reviews. Now going down to the score, now we are at 0.97 from 0.91. Again, another significant jump just by increasing the number of features. And the graph, again, much fewer blues visible. Now let's increase the number of features to the maximum number of features. Now we may not use all 5,000, but let's increase that to 5,000, and let's leave it at that. Let's do that, and then afterwards we will increase the number of trees. So I will be right back. So at 5,000 maximum features, these are the features that we're using, the vocabularies that we're using, classifiers, and we are actually using exactly roughly 1,400. This number is exact. So if we actually do .shape, we get, so this is the number of rows, and it's 1,400 roughly. My apologies. I think we are actually using 5,000 features. The number of columns is the number of features. This is just the number of reviews that are in our training data set. And let's go to our prediction here. It's 99.5 roughly. It did go up, not significantly because we were so high before as well, But if we look at the graph, you can barely see any blues. There's one blue here, there's another blue here that I can see. There is none other that is visible to my eyes, which means that our prediction is getting to be much more accurate as we go on. So I usually use 100 trees for my random forest. So, and you will see that the number, the score that we get will go above 99.5. I will be right back. As you can see, the score went from 99.5, I believe it was, to 99.7. And on the graph itself, this is the only blue that I can see. Everything else is, every other blue dot seems to be covered with a predicted yellow, red dot here. And you can see that the random forest and the bag of words has been implemented on the Yelp dataset. If there are any issues with this, I'm sorry, I am still learning. I am no expert by any stretch of the imagination. But at this point, I don't see, I'm not able to see any issues in the code. So this is an example of the CSV file that is outputted here. This is just an example. I can actually refresh this to the newest version, and let's reopen this CSV file. Okay, let me make it small so it's visible on your screen. Very well. So you can see that the data frame is now visible in a table format on Excel. And if we run a quick correlation on the group, let's see. And on the predicted, let's fix that. K2, let's actually do this manually, it's easier. Okay, so this is the correlation that we get is 0.993, which is extremely high. And you can run regressions and etc. here on the predicted and the stars group, but just visually looking at the two, the predicted and the actual, it's remarkably close. In fact, it's so close that I question my own code. I don't know if I've made a mistake, perhaps, or maybe I'm just using too many trees and too many features, which in a larger database, if you're dealing with a lot of instances, it might just not be feasible to use this many features and this many trees. It might be extremely costly. Anyhow, thank you for listening, and thank you to my professor. I don't know if I should mention his name or not. I don't want to do that and have him not be okay with it. But so thank you to my professor for listening, and you have a great day.